Hello friends, in this video we're going to solve first semester mathematical physics paper of physics honors, Dibrugarh University 2002. Right, I have already solved question papers of mathematical physics question papers of Dibrugarh University of 2019 and 2021. Right, okay. Solution of these 2 years are also available in this channel. I have provided the link in the description box, so if you want to watch them you may go through. Okay, links are in the description box. And before we start, please subscribe the channel, hit the thumbs up button, and also hit the bell icon so that you get notified when new video will be uploaded. Okay, so now let's start. So here is the first question. If z is equal to x square plus y square, then we need to find this is equal to which one, which option is correct. So let me find that. So here you see z is equal to x square plus y square. So partial derivative of z with respect to x, that's going to be twice x, and partial derivative of z with respect to y, that's going to be twice y. So hope you know how to do partial derivation. And now z del z by del x minus del z by del y, so this whole square of this, that's going to be twice x minus twice y whole square. So 2 square is 4 and take in common, and x minus y whole square. So this is the answer. So here is the correct option, right? So now let's move on to next question. So here is the next question. We need to find the order and degree, right? So here you see, so this is dy dx, this is the first degree first order derivative, and this is the second order derivative. So here in this case second order derivative is the highest order, so order will be 2, and power on this highest order derivative is 3, so that's why degree is 3. So option 2 is correct. So hope you have understood this. And a vector, this vector will be sinusoidal if its divergence is 0. Okay, so this is the correct option, question number 3, option 3 of question number C. Now let's move on to next question. Here you see, so Stokes theorem, this one in Stokes theorem, you see this is equal to option 2, right? If you remember the Stokes theorem, this should be the correct answer. Now in this case, grade of r to the power n will be equal to, which one will be the correct option? So let me check. So here you see vector r represents this is the position vector x I cap plus y j cap plus z k cap, right? So its magnitude r, that's going to be equal to root over x square plus y square plus z square, which also can be written as x square plus y square plus z square whole to the power half, right? Whole to the power half. If you take the power of power on r, r to the power n, so then it will be x square plus y square plus z square to the power n by 2, right? So that should be n by 2. Okay, so hope this is clear to you. Now you see grade of r to the power n, so grade of this is equal to, so we can express this in this way, right? So now you see, if you differentiate this partially with respect to x, so if you differentiate it with respect to x partially, then you should get n by 2, then x square plus y square plus z square whole to the power again n by 2 minus 1, right? N by 2 minus 1, then 2 into x. That should that what you should get. If you differentiate this terms within the bracket, then you should get twice x, because we are differentiating with respect to x, right? So now here you see n by 2, this one this x square plus y square plus z square, so it can be replaced by, so here you see there should be n. Now you see this r is equal to, we know that root over x square plus y square plus z square, right? So if you square both sides, right, then you will get on the right hand side this x square plus y square plus z square, right? X square plus y square plus z square. So let us replace this by r to the power 2, right? Let us replace this by r square. So then we will get n by 2 minus 1. So here these two cancels, right? So we can write this is simply n. This is simply n into x. So as you can see, there is I cap. Here you can see this is I cap, right? So if you put here I cap, so there will be I cap here. So then n r to the power, if you multiply this power with this, then what you will get, n minus 2 x I cap, right? That's what we should get. So similarly you can find if you differentiate this with respect to this, right? So then if you find del y here z cap and x square plus y square plus z square whole to the power n by 2, and that's going to be equal to n r to the power n minus 2 if you see the pattern. So here we are differentiating with respect to y, so here y z cap, that's what we're gonna get. Similarly del z, so for k cap here x square plus y square plus z square whole to the power n by 2, right? That's going to be equal to n r to the power n minus 2. So here we should get z and k cap, that's what we're going to get. So now you see this here you can see this left hand side can be replaced by sum of these three results, right? Sum of these three results, okay? So then what you will get, grade of this r to the power n, you're gonna get n. So here you can take this part common, right? N into r to the power n minus 2. So this can be taken common, and then if you take common, then within bracket you should get x I cap plus y z cap plus z k cap, right? So we have taken these three terms common, right? This term common from these three terms, that n r to the power n minus 2, that's taken as common. Then within bracket we have got x I cap, y z cap and z k cap, right? So that is what we have got, and this is nothing but this is your vector r. So your result is, so n r to the power n minus 2 into r vector. That's what you should get, right? So I think here options are wrong. I think this option 3 should be correct. I think there is a printing mistake. So mod of x is continuous but not differentiable, right? So here this function f of x is mod of x, right? So we are to show this is continuous but not differentiable. So it can be defined as plus x when x is greater than equal to 0 and minus x when x is less than 0, right? We can define this way. So now let us find the left hand limit, and that's going to give you limit x tends to 0 minus f of x. So here it's going to be limit, so that x tends to, so here I have taken right hand limit, right? So if you take the right hand limit, then it should be positive, okay? It should be positive. In that case limit, that's gonna be x, if you take the right hand limit for x greater than 0, right? Then this is positive. So if you put 0, then you're gonna get 0. Similarly, if you take the left hand limit, if you find the left hand limit x tends to 0, here it should be minus f of x, that's gonna be limit. So for the left hand limit we have the value minus x, right? So x tends to 0, negative, so here it's gonna be again 0, okay? So if you put 0 here, this minus sign no longer significant here, so that's why we have got 0. as we have got left hand limit is equal to right hand limit, so we can say therefore this mod of x is continuous, right? It is continuous. Now let us check the differentiability. So here you see, so now you see, if you find the left hand derivative, let us find the left hand derivative. If you find that, then it is given by limit h tends to 0. For left hand derivative, you should get f of 0 minus h for h tends to 0, then minus f of 0 divided by minus h, and then in that case what you can do here, you can see, if you put for left hand this is minus x, and for f of 0 minus h you can write minus 0 minus h, right? When f of x is equal to minus x, so if you have f of 0 minus h for the left hand limit, you can replace this minus x, you can replace this x by 0 minus h, so then f of 0 will be here, this is 0, f of 0 is simply 0, so minus h, so that's going to be equal to plus h by minus h if you simplify this, right? So then here you will get minus 1. So if you find the right hand limit, let me right hand derivative, if you find the right hand derivative, then what you will get, limit h tends to 0. So here we're going to write f of 0 plus h and minus f of 0 divided by plus h, right? So in that case, here you see, for the right hand limit, so f of x is equal to x. So now let us replace this x by 0 plus h, then you're gonna get 0 plus h minus f of 0 is simply 0 by h. So let me write here, I forgot to write the limit here, sorry, let me write the limit here, okay. Limit h tends to 0. So here limit h tends to 0, here we have got h by h, so here it's gonna be 1, so it's gonna be 1, this answer is 1. So as you can see that left hand derivative is not equal to right hand derivative, so therefore this mod of x is not differentiable, So hope you have understood this. Now let's move on to the next question. So here you can see that find the value of m, these three vectors, a vector, b vector and c vector, these are coplanar. So what is the condition for three vectors to be coplanar? Their scalar triple product must be 0. That means scalar triple product must be 0, right? So this should be equal to 0. So here first mention the given vectors. What are the vectors given here? Vector A is equal to your this is 2I cap minus 4j cap plus 5k cap, right? And vector B is equal to nothing but I cap minus mj cap plus k cap, right? And vector C is your 3I cap plus 2j cap minus 5k cap. That's what you have. So now how to evaluate this? Just 2 minus 4 5 1 minus minus m, then 1. So then for this vector, see, you have got 3 2 and minus 5, right? So then it should be equal to 0. Now let us expand this. If you expand it 2 into, then minus m minus 5, that's going to be plus 5m. 5m minus 2 1 the 2, right? That's 2 1 the 2. So then minus, let us take minus 4, then 2, sorry, not 2. So 1 into minus 5, that's going to be minus 5. Then minus 3 1 the 3, right? 3 1 the 3, that's what you will get. Then again we have 5, so let's put 5 here, 5, 2 1 the 2, then minus 3 into minus m minus thrice m, that's going to be minus minus plus thrice m. That's what we should get. That's equal to 0. Then if you simplify this, then what you will get, 5 minus 2, that's going to be 3. So here I have forgot to put something here. That should be plus 5m, right? So I forgot to put the m here, so that's why 10m minus 4, then minus minus plus, that's going to be minus 8, then plus minus minus 8 for the 32, then plus 5 to the 10, then 5 to the 15m. Here we have got 15m, right, equal to 0. So 15 and 10m, that's going to be 25m. Then minus 32 plus 10, that's going to be minus 22. Then minus 22 minus 4 minus 26, that's going to be equal to 0. So here 25m will be equal to plus 26. So m will be equal to 26 divided by 25, right? 26 divided by 25. That's what we have got. Okay, so hope you have understood this. Now let's move on to next question, that is question number 2c. So here it is given UP is the orthogonal coordinates, and HP represents the corresponding scale factors. Then so this relation, so it's very simple. So here you see, suppose we have a scalar function. So let me write here. So we have considered that phi be a scalar function of orthogonal curvilinear coordinates u1, u2, u3, right? So in this question they have represented this tree by UP, right, where P is equal to actually 1, 2, 3, right? You can consider that way, right? So then you see, let me write here, this thing is, so then we can say that grade of phi is equal to, that is this, hope you know this relation, that grade of phi is given by 1 by h1 del phi by del u1 plus 1 by h2 del phi by del u2, then e2, then plus 1 by h3. So let me write here, just wait. So this is the grade phi, and here h1, h2, h3 and e1, e2, e3 are, let me write their meaning. Okay, so now here you can see, so what we're going to do, that we're going to replace phi. So let me show you something here on this side, right? Here you see, if you take phi is equal to 1, u1, sorry, taking phi is equal to u1, then what you can write, that if you replace phi is equal to u1, then these two terms will be 0, and this one will be u1 by h1, right? Then you will get grade u1 will be equal to 1 by h1 into del u1 by del u1, that's going to be equal to 1, and e1, which is equal to e1 by h1, right? So we're going to get that, so which can be written as e1 h to the power minus 1, h1 to the power minus 1. So if you take the mod of this, then you have to write mod of e1 then h1 inverse. So it is a scale factor, so just write h1 to the power minus 1. So here you see, similarly taking phi is equal to u2 and u3, we get that mod of u2 is equal to mod of e2 h2 inverse, and we will get mod of grade u3, so is equal to mod of e3 h3 to the power minus 1. So from these three expressions, right, from the above results, we can write so instead of writing three different equations, we can represent these three equations with the help of a single equation, that is grade up is equal to mod of ep h to the power minus 1, so hp to the power minus 1 actually. So and here you see this is unit tangent factor, so its magnitude will be 1. Mod of ep means its magnitude, that's going to be 1. So here del up is equal to 1 into hp to the power minus 1. So here you can see that p is nothing but, or p is 1 2 3, right? So if you put p is equal to 2, then you will get this equation. If you put p is equal to 1, then you will get this equation, first one. And if you put p is equal to 2, if you put p is equal to 2, then you will get this equation. And if you put p is equal to 3, then you will get this equation, right? So hope you have understood, and that is what we needed to prove. So this is the last expression that we wanted to prove, that this is the expression, right? So hope you have understood this. Now let's move on to next question. Now here we need to show that Green's theorem also can be expressed in this form. So if you remember the Green's theorem, it can be written in this way. Let me show you how. So here is the Green's theorem. This is suppose 1. So this is the Green's theorem. So let me show you, this can be expressed in this form as given in this question. So now you see first this part m dx plus n dy, that can be written in this way: m I cap plus n z cap dot dx I cap plus dy z cap, right? And here let me consider this vector. This vector is suppose vector a, and this is suppose position vector dr, right? A derivative of position vector dr. So here you see this is suppose equation number 2. So here vector a is nothing but vector a is equal to m dx m dx, not m dx here. That is m I cap plus n z cap, and dr vector is nothing but dx I cap plus dy z cap. So hope you have understood this. Now you see what we can do here. We know that curl of vector a. How to find that? So this is given by so let me find a curl, right? So del cross a, that is I cap, j cap and k cap here, and vector a, del is here, del by del x, del by del y, and we don't have z component here, so del by del z. That's why when you will write the coefficients of vector a, then you have to write m and 0, because we don't have the z component here. So now if you find this, if you expand it, then what you're gonna get, that minus del n by del z, right, I cap. So for I cap, this one should be taken, that's gonna be 0 minus this, right? So derivative of n with respect to z partially, then minus, then then minus z cap. For z cap we have to take this one and this one, that's going to be 0 minus, then del z of m we have to take del m by del z, right, minus, so it is z cap, then plus k cap. For k cap, what we can take this 2 del n by del x, then minus, then this 2 del m by del y, and this is into k cap, right? That's what we get. Now you see that if you take, let me go to the next slide. Here you see this is I cap. Let me clean these things. Okay. This is I cap, and let me copy this step, and I'm gonna go to the next slide, a new slide. So this is the step, then let me copy it. So here is the new slide, let me paste it here. So this is the result we have got. Let me make it clean. Okay, that is what we're gonna get. Right now here you can see that what if del cross A, so take dot product k cap here, then so that should be taken on both sides. So here you see we have I cap here, I cap dot k cap, that's gonna be 0, right? So this term gonna be 0, and z dot k, that's gonna be also 0, this term also will be 0, and k dot k, that's gonna be 1. So we will get so what we're gonna get, we're gonna get del n by del x minus del m by del y. That's what we're gonna get, right? So hope you have understood. This is suppose equation number 3. Now what we're gonna do, let me use this equation number 2. Let me use the equation number 2. Here you can see, so this is the equation number 2, m dx plus n dy a dot dr vector. This is equation number 2. Let me use this equation number 2 in 3, right? Let me use equation number 2 and 3 both in equation number 1. So we can replace this by this result, right? A dot dr vector. Then we can replace this part by this curl of vector A dot k cap, and this dx dy is nothing but here it can be dr, right? So using 2 and 3, 2 and equation number 3 in equation number 1, so we will get, so this is close integral a dot dr is equal to r here curl vector of A, then dot k cap dr. That is what we needed to prove, where dr is nothing but your dx dy, right? Dx into dy. So this is what we wanted to show. This is the Stokes Green's theorem, which can be written in this form. So hope you have understood this. Now let's move on to next question. So here we need to prove use the property of Dirac delta function to evaluate this. So what we have here, integration minus infinity to plus infinity e to the power minus 5t delta t minus 2 dt. That's what we have. So if you compare this one with this property, that here you can see we have a property that minus infinity to plus infinity f of t, that is function of t, then delta t minus t naught suppose dt, which is equal to f of t naught, Let me use that. So here you see, if you compare this ft with e to the power minus 5t, so here f of t is equal to e to the power minus 5t, then compare this one with this, so then what you will get, that delta t to the power delta t minus 2, that's going to be equal to del of t minus t naught, and if you compare these two, then you will get that t naught is equal to 2 here, right? So comparing these two, you will get t naught is equal to 2 here. So we know this property, right? Let me write here, we know this property. So just wait. So what we can do here, so minus infinity to plus infinity e to the power minus 5t, and del t naught minus here, t minus 2 here, we have dt, and so here we will get f of 2, because t naught is 2 here in this case. So f of 2 here, f of 2 is nothing but, in this case that's gonna be, so here f of t is this one, so that's going to be e to the power minus 5. T is here, f of here t naught, that's going to be in this case e to the power minus 5 t naught, and here t naught is 2, so here we're going to get 2, right? So here it should be 2 only, so that's equal to 2 into 2, right? So e to the power minus 10, that's what we have got, or 1 by e to the power 10. So that is our answer. So hope you have understood this. Now, so in the next video we're gonna start from question number 3, and it will be it gonna be appear at the end screen if uploaded. Okay, if it is not uploaded yet, then it's not gonna appear. When it will be uploaded, it's gonna appear at the end of the screen. And this is the first part, and I will complete this paper in next 2 or 3 parts, and I have provided the links of those video solutions of mathematical physics paper of 2019 and 2021, right? So check the description box, so you may get the links of those previous lecture. So thank you for watching. Support me to create new contents for you, inspire me, and help me to grow my channel, and stay connected. Thank you for watching. See you again in the next video.